All right, here we go. 313, number 4. Use a calculator to find polar coordinates. I'm looking for an ordered pair. I'm starting with an ordered pair. I'm going to end up with an ordered pair. And I'm going to need a calculator, obviously, because 3 and 4, while they're very special numbers, are not on my unit circle. There's ratios and on my unit circle. So I'm going to take a look at where I'm at. Over 3, down 4, so my radius is 5. Don't need a calculator for that, right? But I have no idea what this angle is. So I'm going to get my calculator out. And what am I going to press to find that angle? Second tangent, 4/3. Now, I didn't put the negative in. I found this angle to be 0.927. If you do put the angle or the negative in, you're going to get negative 0.927. Same thing, right? I'm just drawing a picture of it in quadrant 4, so that angle will be negative. Now, some of you wrote negative 0.927. I want you to look at the directions, and theta is supposed to be between 0 and 2 pi. So does that angle qualify? No, it's not that it's the wrong angle. It is the right angle. It just isn't written in the form we need it to be. So the right angle would be the one between 0 and 2 pi, which is that one, right? So what are we going to do?
Add 2 pi.
Yep, if you have the negative, you're going to add 2 pi. I'm going to subtract 2 pi because I've got the positive here. So it's going to be 5.356. So 5.356 is the correct answer. All right, everybody okay with that? Anybody have another question quickly on this homework before we wrap up the stuff?
Can we look at 314?
Yeah, we'll do one for 314. Which one?
Number 6. On the back.
6. All right, 6 says, portion of the graph of the polar function, and the function is 3 cosine 3 theta. And I want to know, okay, so here's what I'm going to do. I'm going to go ahead and graph this thing in rectangular form so I can kind of see when things are increasing and decreasing and stuff. So 3 cosine 3x will have an amplitude of 3 and a period of what?
2 pi over 3?
2 pi over 3. It's cosine, positive cosine. So it's going to look like this. Now, I haven't graphed it over the entire 0 to 2 pi. I've done just one period of it. But I know if I need it, I can continue this on and basically just graph that thing twice more if I need to. Let's see if I need to do that. All right, so which of the following could be values for A and G? Oh, wait a second. What picture? Wait, which one am I doing? 6?
6.
And is 6 is the picture above it, right?
Yeah.
Okay, so I've got part of the polar graph drawn like just this much right here. Right? Okay, so let's see what's happening there in that much of the graph. Let's see, my choices are 0 to pi over 6. What's happening from 0 to pi over 6? In the rectangular graph, we are moving from 3 to 0. So in this case, I gotta be careful, because which direction am I going? Okay, so I'm just gonna put pi over 6 into here. If I put 0 into this, if I put 0 into this equation, I get 3, so that point would be over here, so that doesn't work, I'm not using that one. Okay, my next one is pi over 6 to pi over 3. Okay, if I put pi over 6 in, pi over 6 would give me 0. Okay, that could work. What if I put in pi over 3? If I put in pi over 3, I would get pi, and that would be negative 3. So that pi over 3 would go here. That looks like that will work. But I don't have that answer down here.
Let's see.
Let me try the next one. Pi over 3 to pi over 2. All right, I just did pi over 3. Pi over 3 was here. And pi over 2 is 0. Okay, so the question, Bryce, is this point and this point are both good. I just have to figure out which direction I'm going, okay? So, as I'm moving from pi over 6 to pi over 3, now remember, the pi over 6 point was this one, and this was the pi over 3 point, okay? Look at your picture. From pi over 6 to pi over 3, we are moving away from the origin, away from the pole. What are we doing from pi over 3 to pi over 2? We're getting closer to the origin. So well, I did this one, and I got, what did I get? I got this, didn't I? Yeah. Okay, so if I continue that, this is the way this curve is going. So from 0 to pi over 6 is this. And when that continues, it continues like this. It goes around like this, and then up like this, and then back around like this. So I am going from pi over 6 to pi over 3, and then back to here. So from pi over 3 to pi over 2, I'm getting closer to the pole. I don't know why I was so sure it was C. What am I missing? Does anybody see it?
Wait, you just said.
Well, the problem, I think that this is what I thought was the answer, and I still think it is. But I don't know why I didn't pick that one, because from pi over 6 to pi over 3, I am moving away from the pole. Oh, but wait, this is the piece I'm looking at, yeah, I only have that piece in my picture, so that is the one I need, yeah, that's the one I need. So let me back up, I grew too much up here and got myself all confused. I know that my picture is going like this is how my picture is going, because I plotted a couple points. This is the part of the graph I'm interested in, that's the only part he drew. So from pi over 3 to pi over 2 is where I'm getting closer to the pole. Yeah, that's it. That's it. Moving in that direction. If he had drawn this part of the picture, then that would be the answer.
Will we ever have to, like, will the question ever be stated where we have to find where it's dotted instead of where it's a solid line? We're always like to be a solid line.
Because you don't have to freehand graph any of these. I do, because it helped me figure out which direction I was going. Because if they only give me this, I'm not sure if I'm going this direction or this direction. So when I did the first point, that told me, okay, this is the way I'm going.
So do you have to use the first one in order to get the direction of where it's going.
I do. I don't know. Now, yesterday we did talk about, I don't know if this class in your class, cosine graphs. Because the cosine of 0 is 1,
Right.
cosine graphs are gonna start out here at the end of their petal. So if you can remember that, then you know it's gonna start out there. So that petal is gonna go like that, and then they're connected, one smooth flow. So once you start drawing, it just keeps going. So you'll never go like this and then like this. They just keep going in an arc. Once you get started, they just, no matter how many there are, they just keep going around that way. All right, there's one more kind of like that, I think in our homework, or no, in our worksheet that we didn't finish yesterday. So let's get out the one that says 3.13 worksheet, but it's got the 3.14 in it, and I don't think we did the last problem. So let's take a look at that last problem on the worksheet, where again, it says exactly the same kind of thing. We've drawn a part of the graph. And we have to decide what section of the graph that is that we're drawing. So it's on the very back side of the worksheet 2.13, but it's the very back side of it. We'll try to figure out what's going on. This is such good practice for us to draw these things in rectangularly, because you will have to generate those terms perhaps. So cosine. I think it behooves us, this one's been lifted, has a vertical shift. I think it behooves us to find our zeros. Where do we cross the axis? Because remember, those are the points where we'll be at the pole. That's where you're at the pole. So we need to find those values. So how will I find those two red points? What will I do to find where I have an actual 0? Now, if I plug a 0 into y, yes, set the equation equal to 0 and solve it. That's exactly right. So 2 plus 4 cosine equals 0. So 4 cosine is -2. Where is the cosine -1/2? Cosine -1/2. Where does that happen? Pi, 2 pi over 3, and 4 pi over 3. So for those 2 points, and those 2 points only, in this part of the domain, and I don't know if you noticed, he went all the way back here. On this one. But in that part of the domain, those are the only 2 places where we're going to equal 0. Any thoughts on where these 2 would be back here? Yeah, isn't this symmetric, guys? So if that's 2 pi over 3, this will be -2 pi over 3 and negative 4 pi over 3. So in the domain that he's given us, those would be the 4 points where we're at the pole. That's it. So it looks to me, if I look at this loop that he gave me, isn't this loop, start at the pole and loop it around, it's at the pole twice in that loop. And keep in mind, you need to think about what the whole thing looks like. It's one of these deals, right? So it's gonna, in naturally drawing it, it's gonna be at the pole at some point and then loop around and come back through the pole again. Okay, so in other words, it's at the pole, moves away, and comes back. Looking at the rectangular graph, I'm gonna stick with the positive part first. Looking at the rectangular graph, here's where it's at the pole. What's it doing in between? It's moving away and coming back. Isn't that exactly what we need it to be doing? Plus, what is its furthest point away? When it moves away, how far does it move away to? What's that? It's 2 units away. Because, look, what's your vertical shift? 2. What's your amplitude? 4. So you're 2 units under that. Is that what's happening in the picture? Am I starting at the pole, moving 2 units away, and then moving back? I absolutely am. So that should be your interval right there, I hope. Let's see. Oh, that's what I said it was when I did it before. What happened over here? Why did I not choose this one? Oh, this one was from here to here. Well, wait a second. Between here, doesn't R get all the way out to 6? So that can't possibly be right. Because here your R has to be 0 to 2, is it? Your radius is 0 to 2 in that section. Okay? All right. Now, I'm going to give you some notes and homework for this. While I'm handing out the notes, would you start reading that pretty basic stuff? All right, everybody got one? Okay, the homework's up here, so we'll get it in there. Okay, this last section has a lot of overlap with what we were just talking about, but now we're talking about rates of change. Rates of change, which kind of is interesting because that's where we started back in Unit 1, and that's where we're ending up here. So, I have kind of highlighted when I read the notes that third line that says, as we trace the graph of a polar function, we are interested in whether it is getting closer to the origin or farther from the origin. Well, that is exactly what we were just talking about here, and using that idea. So, as you move away from, if you're looking at it rectangularly, as you move away from the x-axis, R is getting bigger. And then here your distance is getting less. So that's how we incorporate the rectangular part. All right, let's look at example 1. The picture is rectangular, drawn for you, and you have to fill in that little chart. Well, where is the function positive and increasing. Well, can you give me some intervals where that's happening? Positive and increasing. Look at the rectangular curve in example 1. Where is the function positive? There's y positive and increasing.
0 to pi over 2.
So 0 to pi over 2. Is there any other part of the curve that is positive and increasing?
11 pi over 6 to 2 pi.
Perfect. There you go. That's where we are positive and increasing. Okay, where are we positive and decreasing? Pi over 2 to 7 pi over 6, and I think that's the only one. Negative and increasing.
3 pi over 2 to 11 pi.
Beautiful. And negative and decreasing.
7 pi over 6 to 3 pi over 2.
Perfect. Okay, that's easy enough. Now, we're going to go down and we're going to fill in what is happening to the distance between our function and the origin. Well, he's already filled it all in, hasn't he? Okay, well, let's look at it and make sure it makes sense to us. So between 0 and pi over 2, you said the thing was positive and increasing. Does that make sense to you that that means r is growing? Now, where you have to be careful is when you go back, when it's negative and decreasing, the distance is actually increasing because you're going down, you're moving away. It's decreasing and you're moving away because you're negative. Okay, all right, let's try an example. Example 2. Consider this graph, which is very similar to the one we just did. Which of the following statements is true about the distance between the point and the origin? Okay, why don't we graph this rectangular? You guys need to practice this, don't just copy mine down. What's our vertical shift? 2. I'm drawing my vertical shift. What's my amplitude? So that's 2. So 1, 2, 6. Now be careful. This cosine is negative, so he will start down here. Oh, wait a second, I need to plot. What's my period? Too high. So what do you think about that? Is that okay? What are these? We need to find the zeros too. They're very, very helpful. Incorporated in any problem that talks about positive and negative functions, you have to know where you cross the axis. So how do I find those again? Yep, so 2 minus 4 cosine equals 0. Negative 4 cosine equals negative 2. Where does the cosine equal 1/2? Pi over 3 and 5 pi over 3. All right, so these are the points I'm interested in. All right, so let's see. A, the distance is increasing for pi, here's pi, and here's 5 pi over 3. The distance, whoa, the distance is increasing. No, that one's gone. All right, B, the distance is increasing for 5 pi over 3 to 2 pi, is that true? Because f of theta is negative and increasing on the interval. No, no, this is not, this is negative, but it is not increasing on the interval. So the statement is right, but the reason is wrong, so cross B off. Does that make sense to everyone? C, the distance is decreasing from pi to 5 pi over 3 because the function is positive and decreasing. True. C is true. The whole thing is true. Agreed? Just for fun, let's look at D. We know it's probably not going to work, but let's look at it. The distance is decreasing for 5 pi over 3 to 2 pi. No, the distance is increasing, so that's not. All right, give example 3 a try. I think it's exactly the same kind of thing. So they drew it for you, the picture's drawn in example 3. See if you can figure out what's going on there. All right, what'd you come up with? Were you able to come up with an answer? C. I wrote down, I just went through and wrote down all the intervals where the distance, we're not talking about the function, guys, we're talking about the distance is decreasing. Isn't the distance decreasing right here? And right here, and right here. So I just have to find one of those answers, and it looks like C is one of them. This should be C. All right. Everybody okay with that? All right, now we're talking about extrema. Kids, there's no great mystery here. What happens at an extrema? You change from being increasing to being decreasing, or from being decreasing to becoming increasing. And it doesn't matter. I think it's easier to see in a rectangular system, but the same holds true in a polar system. If R is increasing, if you go, think about one of these shapes right here. If you go, you head out, and then you turn around and come back in. Isn't that an extrema right there? Because you change from being increasing to decreasing. Okay? So now our job is, I suppose, to try to find some of them. So let's try example 4. Consider the graph. Okay, so what does this one look like? Rectangular, like y equals 1 minus 2 sine 2x. Has a vertical shift of 1. What's my period? Pi?
Pi.
It's a sine curve with an amplitude of 2. now we better find where I cross the x-axis, better find my zeros. Where do those happen? Here and here. So 1 minus 2 sine 2x equals 0. So negative 2 sine 2x equals negative 1. What angle has a sine of 1/2?
Isn't it a negative sign?
Oh gosh, yes it is, thank you. Thank you. Yeah, that would become apparent here in a couple minutes. Because now that's gonna change where my zeros are. They're not over here anymore. They're over here, which is exactly what that equation is gonna tell me. Thank you, Julia, very much. Okay, so I got the equation right. I think I just need to figure out where does the sine equal 1/2? Guys, where's the y coordinate 1/2? Pi over 6. So your angle equals pi over 6, or what's the other one? 5 pi over 6. So where am I crossing the axis here? This is pi over 12. And this one is 5 pi over 12? Okay. Now, what am I doing? The graph has a relative minimum on the interval from pi over 3 to 2 pi over 3. Wait a second. Wouldn't pi over 3 be in here somewhere? And 2 pi over 3 would be over here somewhere? Is there a minimum in that interval? Okay, that one's out. A minimum on the interval from 2 pi over 3 to pi. Is there a minimum on that interval? No. How about from pi over 3 to 2 pi over 3? Is there a minimum on that interval? No. How about from 2 pi over 3 Oh, maximum. Oh, I'm sorry. Now I'm looking for maximum. Okay, so let's stick with that one. 2 pi over 3 to pi. Is there a maximum in that interval? There sure is. So D is the answer, even though I didn't do C. Pi over 3 to 2 pi over 3 has no maximum. So the answer has to be D. Does the function in this interval change from being increasing to decreasing? Yes. So the whole thing in D is true. There's a maximum in there. Here's pi over 3. Here's 2 pi over 3. Here's 2 pi over 3 is here, and pi is here. And there was a maximum in there, and we're going from increasing to decreasing. That seems okay. All right. Now, average rate of change. Who remembers how we find an average rate of change? In function notation, and we need to get used to using function notation, it will be f of, if the interval is the interval from A to B, it will be f of B minus f of A over B minus A. So that's it is slope, it's y minus y over x minus x, but you need to get in the habit of writing it this way. Okay, now we will have our function is this, and our interval is pi over 2 to pi. Here we go. We do it just like we've always done it. So we'll take f of pi minus f of pi over 2 you divide it by pi minus pi over 2. Nothing new, just doing it with angles now, and sines and cosines. So here's your function. So what happens if we put pi in there? What is the cosine of pi? -1. So if that's -1, this would actually be 3 plus 3. So that's 6. Now, what do we get if we put in pi over 2? Cosine of pi over 2 is 0, but it's 3 minus 0, so it's 3 over pi over 2. So we have 3 divided by pi over 2, which is 6 over pi. Yep. Now, that's going to happen. I mean, you're going to get things that look like that. You're not going to get like 2/3 usually. That's it. Isn't that easy? Easy peasy. All right. Example 6. On which of the following intervals is the average rate of change equal to 0? Now, some of you guys are really, really smart and you see things really, really easily. But one option we have to answer this question and questions like it would be to simply find the rate of change on every interval and compare them. So that would be one option. So if our interval is pi over 4 to 3 pi over 4, what will our rate of change be? Well, so we start with this one. So if you put in 3 pi over 4, you get 3 pi over 2. What's the sign of 3 pi over 2? -1. So we're going to have -3 minus, okay, now put in pi over 4. Pi over 4 would be pi over 2. Sign is 1, so that's 3. Over these two subtracted from each other, so that would be pi over 2. So that one is going to be -12 over pi. Remember, what am I shooting for? What am I trying to get? 0? So I really only care about, are these going to cancel each other out? I need a 0 up there. So let's look at 3 pi over 4 to 5 pi over 4. Okay, if we put 5 pi over 4 in there, that becomes 5 pi over 2, which is where? Pi over 2. So this one's going to be 3. All right, now put in 3 pi over 4, that becomes 3 pi over 2. That one is going to become what's that one going to be? -3. Oh, is that going to be 0? Yep. Oh, no, it's minus -3. Here's our formula, guys, right here. I'm subtracting. So I do get -3, but I'm subtracting, so that is not a 0. That one doesn't work. How about the next one? That one's going to give me 7 pi over 2. Where's 7 pi over 2? Isn't it down 3 pi over 2? So that one's going to be negative. I'm subtracting. This one's going to give me 3 pi over 2. I think that's the one that gives me 0. Because this would be 3 sine, 7 pi over 2 minus 3 sine 3 pi over 2. This one's negative, that's minus another negative, so yeah, that one works. All right, one more. Figure this out, see if you can do it in 5 minutes. Which of these has the smallest rate of change? The smallest rate of change, which of those intervals? The graph has no holes, passes through each point exactly one time, and as theta increases, the graph passes through the labeled points A, B, C, D in that order. So A to B to C to D. So it's just going around the circle. So what angle is A? 0. What angle is B? Pi. What angle is C? 5 pi over 4. And D is 7 pi over 4. So you're trying to figure out what's the rate of change from 0 to pi. That's A to B. What's the rate of change from pi to 5 pi over 4? That's B to C. That's what you're trying to figure out. A is the point. What is that? 2 point or 3? I'll just round it off, say 3. A is the point 3 comma 0. B is the point 3 comma pi. C is the point, I'll just say 5 comma 5 pi over 4. And D is the point 5 comma 7 pi over 4. There are your points, kids. This time, instead of having to plug them into an equation, they're given to you. Now, I kind of approximated these guys, but since I made them the same, it doesn't matter. Okay, so what do you think? This is going to be pi minus 0 over, or, so F 3 minus 3 over pi minus 0. This one is going to be 5 minus 3 over 5 pi over 4 minus pi. This one is going to be 5 minus 5. And D to A is going to be 3 minus 5. Okay. All right, what do we come up with? A to B, I got 0, did you? What about B to C? I got 8 over pi. D, I got 0 again. smallest one, I actually got a negative number. Did you get negative 8 over 5? So what did I want, the smallest one? That would be this guy right here. All right, grab a homework on the way out. We still have one more thing to do, and it's kind of an important thing. So we'll wait and do that. That'll actually, will I see you on Monday? Yeah, no, Class on Monday. So that will be part of it. So this is going to be assigned on Monday, so it'll be due Wednesday. Pick it up now so you have it. Pick it up so you have it. Not due until Wednesday. Might do a couple of them. Shoot me an email if you want me to do